Hey, welcome back to POE. Today we're going to be talking about an introduction to series circuits. A series circuit is a circuit that contains only one path for the current to flow. If the path is open anywhere in the circuit, current stops flowing to all the components. So in this problem here, we know that it's going to be the flow of electrons. All right. Now this is the real current, not the conventional current. Conventional would be going, that's conventional right there. This right here is the actual current, and it goes through the light bulb and gets here. If for whatever reason, sometimes these filaments up here in the light bulb, if those were to break, then the current just stops right here. It isn't able to keep flowing, and that's what they're showing here with that light bulb being off. Okay, series circuits. What they want to show us here is that with series circuits, we have to find, or one of the things that we can find is the total resistance. That's RT. And what we do with that then is we simply add them up. So in this case, RT would be adding all of our circuits up. 1.2 kilo ohm, that's 1,200. This is a 470 kilo ohm, and this is a 220, not kilo ohm, 470 ohm, this is a 220. So overall we have 1,890 ohms, and that's simply by just adding them up like we see here. That's how we find the total resistance in a series circuit. Okay, steps to find the components in a series circuit. These are our 4 steps that we're going to repeat over and over and over again. Find the total current. Find the total resistance. Then we're going to find the total current. We're going to use characteristics that we're learning. And then we're going to use our equation V equals I times R. Okay, one of the characteristics that we've got to learn is that for series circuits, and this is for series circuits, as I said, the current is going to flow all the way through here. So if we have 4 amps of current here, then we've got 4 amps of current here, 4 amps of current there, and 4 amps of current there. What this means is that all components get the same current. All right, all of them are going to get the same current, and that's important for series circuits. Okay, one of the things that I'm going to ask you to do quite often is we're going to talk about fill in the box or fill in the chart. Well, the way we go about doing that is we're given a schematic here. Here's a schematic, and this is a series because as we look at it, as the electricity flows, it has no multiple paths. All right, there's no multiple paths. Now up here they talk about IT going this way, and that's because they're talking about the conventional current, not the actual current. But let's talk about filling in the chart. All right, first of all, I'm going to fill in what they give me. Here they tell me that it's 12 volts, so I'm going to go up here and put 12 volts up here. They tell us that we have these 3 resistors, so I'm going to fill these in. 220. Resistor 2 is a 470. Resistor 3 is a 1200 ohm resistor. All right. I've filled in everything they've given me at this point. So now it's time to start going through our steps. First step, find the total current. Find the total resistance. I keep saying that wrong. Find the total resistance. Well, we did that just a few steps ago. What was our total resistance? Well, we simply added them up. Resistor 1 plus a resistor 2 plus resistor 3 gave us our total resistance. They gave us RT. So I can put that 1890 in right here. Second step, find IT. Well, how do we go about finding IT? Well, the nice thing is we've got V and we've got R, so I can use Ohm's law and say that V equals I times R, or 12 equals I times 1890. And my, do we have some current here. The current equals 157.5 amps. My apologies, I'm in a hurry. We actually get 0.0063 amps. This is my IT. I took 12. I took 1890 divided by 12. I need to take 12 and divide it by 1890. So my total current is my total current. That's IT. And that's simply by just using the steps we know. Well, what's the next step? Use the characteristics we know. Well, what do we know about series circuits? I'll tell you what we know about series circuits. Series circuits, all components get the same current. So I can go in here and say if my total current is 0.0063 amps, then everything is going to get that exact same current. Having said that now, let's look at our last step. Use the equation V equals I times R. Well, in each of these cases, I know I and I know R. All I need to do is multiply them. And we get 1.7 volts, 2.96 volts, and 7.56 volts, simply by multiplying the current times the resistance. One of the things I also want to point out to you is Kirchhoff's law. And that means that we can take our VT and simply get it by adding up the other voltages. So this is a way you guys can always check to see, am I correct? And because we're rounding, we're not going to get an exact number. But if I add them, I got an answer of 12.22 volts, which is really close. Typically, that almost caused for me to almost want to go back and look at my answers and see if I was off somewhere. But I didn't get an answer of 15. I mean, we should get an answer exactly of 12.22, so why am I off? Because I rounded. Okay, some things I'm going to talk about real quickly here. It's a diode. It allows current to flow in only one direction. We used an LED, which is not exactly a diode, but it kind of served the same purpose for the lab that we're doing. But I don't want you to confuse those two. A diode and an LED are not the same. Again, it allows current to flow in only one direction. Resistor. It's an electronic component that resists the flow of electrical current. Quite often it's going to heat up, but what I want you to know about it is these little resistors like this are inside almost every electronic device, and we're going to teach you how to read that. Types and package styles. We have what's called a potentiometer. A potentiometer is kind of like a dim switch. As you can turn it, it's going to start over here, and basically as you turn it, it moves in one direction and adds resistance, or takes resistance away. Your light bulbs are going to get brighter on a dimmer when you reduce the resistance. Think about it all. As the resistance goes down, the current's got to go up, which means that the lights are going to get brighter. Carbon film resistors, and then carbon film resistors. So these are all different types of resistors that you guys will run into. Here's pretty much actual size. If you think about this being a quarter, but this is the real size of these resistors. Okay, let's start with the color code right here. All right, here's where I'm at. The resistors are labeled with color bands that specify the resistor's nominal value. The nominal value is the resistor face value. They tell you it's too small to put writing on it, so they use this colored system here. All right. Things I want to point out to you. We use the first two bands to find out what the first two numbers are in the resistor. The third band tells you what to multiply by, and the fourth band gives you the tolerance. This is a gold, which would be a very expensive. Silver is a little bit less expensive. And then if they have no band, you can assume it to be a 20% tolerance, which means it could be plus or minus 20% of the value that you got a reading for. So let's go ahead and look at a few here. In this case, our first one is brown, which means it's going to be a 1. The second band is a black one, which means it's going to be 0. The third band is a red, which means we're going to multiply that by 100. Well, 10 times 100 is 1,000. So this tells us it's a 1,000 ohm resistor, and it's only got a plus or minus of 5%. That means this right here would be as much as 1,050 or as little as 950 ohms of resistance. The more expensive means you're going to have less variability right there. All right, I want you to find this one on your own. Your first number is obviously the orange. Your second number is the white. Your third number is your multiplier, which is the green. And then you need to find the tolerance. right? And what I want you to do is find the min and the max with that as well. What's the minimum number it could be? What's the maximum number it could be? I would take an extra minute to get this down here in my engineering notebook so that I'd have this to look at. You're going to be tested over this. Shouldn't be too hard for you brainiacs, but hey, I'll catch you guys on the flip side.